Welcome to this Switch On Skills webinar. My name is Dr. Nathan Coos and I work at Swansea University with a background in materials engineering. And today's topic, we're going to be discussing introduction to renewable energy technologies. On the screen, you'll see a QR code that'll take you to our website. And from there, you can also find the schedule of webinars that we've got happening in February, and we've got one a week now until the end of the month. And I'll be putting that QR code up at the end as well, so don't worry if you don't catch it now. So the aim of today's session, this is a taster session based on our online course that we have on renewable energy sources and technologies. Traditional technologies for large-scale electricity generation like coal, natural gas, oil, and nuclear energy have environmental impacts that can be catastrophic, not only for the environment, but also for the people and the economy of the areas affected. So, for example, we have, if we look back into the history books, we have the Chernobyl nuclear disaster of 1986 and things like the Gulf of Mexico oil spill as well in 2010. Renewable energy offers a cleaner and potentially safer and more sustainable approach to energy and power generation. And this sector has seen major advances and investment in recent years, with many new technologies increasing efficiency and enhanced the technologies. And these will be discussed in the following sections. Renewable energies, things like solar, wind, hydro, geothermal, to name a few. And these technologies utilize the energy from natural sources like the sun or the sea, so they're considered to be renewable. And in many cases, this energy is harnessed using ever-evolving technologies to generate useful power. So why? Why is this important, and why is it important now? There's an increase in demand for energy at the moment. As technology moves on, we need more energy to run it. We have diminishing stocks for fossil fuels. We can't keep using these fuels indefinitely. And we also have the world sort of has a stronger desire now to lessen environmental damage, particularly by reducing greenhouse gas emissions. This all points to the need for improved materials, technologies, and methods for generating renewable energy. So just to define renewable energy, a renewable energy source means energy that is sustainable. It's something that can't run out or is seemingly endless, for example, like the sun or the wind. When you hear the term alternative energy, it's usually referring to renewable energy sources. And it means sources of energy that are alternative to the most commonly used non-sustainable and non-renewable energy sources, like I mentioned, coal, oil, or gas. Energy conversion from renewables. So we're going to focus mostly on electrical energy, and this is generated from either mechanical, either directly or driven from hydro, wind, or wave and tidal. We also have energy, for example, batteries. These are fuel cells directly converting chemical energy into electrical energy. The photovoltaic effect directly from solar to electric, and also the Seebeck effect, which is from thermal to electric. This is a phenomenon in which a temperature difference between two dissimilar electrical conductors or semiconductors produces a voltage difference between the two substrates to generate electricity. And it's worth mentioning nuclear. Even though nuclear generated electricity isn't classed as renewable, it is low carbon, which means its generation emits low levels or almost zero carbon dioxide, just like renewable energy sources. And it is a stable source, which means it's not dependent on the weather, and it will play a big part in getting Britain to net zero status. So let's start with the first main renewable energy source, and that is solar energy. So sunlight is one of our planet's most abundant and freely available energy sources. The amount of solar energy that reaches the Earth's surface in 1 hour is more than the planet's total energy requirements for a whole year. So if we can even harness some of that, then we should hopefully be on a way to more sustainable energy. And although it sounds like a perfect renewable energy source, the amount of solar energy that we can use varies according to things like the time of day and the season of the year, as well as geographical location. So we in Wales here, we might not get as much as some of the sunnier climates. And that's something that we need to consider for our own energy choice going forward. And in the UK, solar energy is nevertheless becoming an increasingly popular way to supplement your own energy use at home, and we're starting to see solar panels on larger buildings now as well. So I'm going to play this short video going a little bit more into the energy that we get from the sun.
Almost all of the Earth's energy input comes from the sun. The sun is therefore vital to life on Earth, but not all of the sunlight that strikes the top of the atmosphere is converted into energy at the surface of the Earth. Much of its light is reflected. In fact, the Earth's albedo, which is the ability of a surface to reflect sunlight or solar radiation, reflects back around 34%. Snow and ice have high albedo. Most of the sunlight hitting surfaces covered with snow and ice bounces back. In contrast, dark, earthy surfaces have a low albedo. Therefore, they absorb more sunlight. The amount of energy that reaches the Earth provides a useful understanding of the energy for the Earth as a system. This energy goes towards weather, keeping the temperature of the Earth at a suitable level for life, and powers the entire biosphere. Additionally, this solar energy can be harnessed to be used as a primary energy source, either with solar thermal power plants, solar panels, or photovoltaic cells.
Okay, and that video is on our YouTube channel, which again, I'll put a link in the last slide to our YouTube channel. So as the video mentioned, what is solar energy? It's a renewable energy, which is inexhaustible and obtained from the electromagnetic radiation from the sun. It generates electricity and heat in a manner which is sustainable and free once we've built the solar cell. And there's a bubble there on the screen. Is solar energy renewable? Well, solar energy does not produce air pollution or greenhouse gases. And it's also an abundant source of energy. So yes, it's classed as a renewable energy source. A consideration to take into account is the main environmental impact of solar energy is the use of land and then the potential loss of habitat in the case of large solar energy farms. Types of solar energy. Here are 3 main types of solar energy. Photovoltaic solar energy. This is used to produce electricity directly from sunlight. Solar thermal energy. This is used to heat water. So the heat that is harnessed from the sun is then converted then into heating a fluid, so heating water or directly heating the air. And finally, passive solar energy, which directly takes advantage of sunlight, as shown here in the schematic, where, for example, we could have on this building, we could have triple glazed windows that would allow heat energy in, but then doesn't allow much heat to come out the other way. And also there are thermoelectric systems that are emerging, which is something to keep an eye on. We've got solar PV tubes which are also photovoltaic and solar thermal as well. And bioclimatic architecture, things like passive buildings and utilizing the world's natural energy sources in a passive way, is a way of designing buildings based on the local climate, with the aim of ensuring thermal comfort using environmental resources. They must also blend into their natural environments. So this is nothing new because it's safe to say that traditional architecture is intrinsically bioclimatic. So for example, you may see older buildings naturally facing the sun to obtain more heat and natural light in the nicer weather. And that is going to save them on their heating bill. So some advantages of solar energy. We have it's an abundant form of energy, which is renewable and free. There are no toxic or polluting emissions into the air. And it is an increasing competitive energy source. It reduces the need to rely on the electricity grid or natural gas, for example. And there's also subsidies for self-supply, as well as it's a key measure against climate change. We're also reducing the use of fossil fuels and also generating wealth potentially and local employment through things like green jobs. And even though the UK is, unlike sunnier countries, has less days of full sun, we are still able to harness the sun's energy, and solar power is the third most generated renewable energy in the UK after wind and biomass. And it is estimated that around 900,000 to 1 million homes have solar panels in the UK. However, there's some disadvantages to consider when choosing or thinking about choosing solar energy. It can be intermittent and inefficient. So cells are the maximum, we're talking about 30 to 40% efficiency, and many are a lot lower than that. And it's also intermittent depending on the weather and things like shading as well from nearby plants, buildings, and so on. It's a high initial investment. These materials are relatively expensive to purchase and manufacture. And something to think about the location of the homes and buildings. Not every building will be very well suited to solar energy. Moving on to wind energy. Wind energy and wind power both describe the process by which wind is used to generate mechanical power and energy, or electricity, sorry. Wind turbines work on a simple principle. Instead of using electricity to make wind, like a fan, wind turbines use wind to make electricity. So it's the reverse of something like a fan. The wind turns the propeller-like blades of a turbine around a rotor, which spins a generator, which creates electricity. And you may well have seen quite a few turbines popping up around the area where you live or where you work, or in between somewhere. And they're increasingly popular sites on hillsides and offshore wind as well. This mechanical power can be used for specific tasks. So years ago, it would have been grinding grain or pumping water, and still is in some cases, or directly then to power a generator. The generator can convert this mechanical power into electricity. You may be interested in this, but what is wind? It's actually a form of solar energy caused by a combination of three concurrent natural events. Firstly, the sun unevenly heating the atmosphere, irregularities of the Earth's surface, and the rotation of the Earth. So these all things combined will create wind flow. Different patterns and speeds will be generated from these events. Oh, skipped a few there. Right, so similar to solar, wind is a plentiful source of clean energy. And we are seeing a lot more wind farms being built around the UK. And this is making an ever-increasing contribution to our energy production. To harness electricity from wind energy, turbines are used to drive generators, which then feed electricity into the national grid. Although domestic or off-grid generation systems are available, again, not every property is suitable for a domestic wind turbine. I'm not too sure if my neighbours would be too happy if I put quite a large wind turbine in my garden, but maybe they would if I shared the energy with them, I don't know. So I'm going to play another video here on, it's mostly tailored around offshore wind energy, but many principles are relevant for onshore wind as well.
Today, we will learn more about the exciting world of offshore wind energy. Ever wonder how those giant wind turbines out at sea work? Stick around, and we'll explain everything you need to know about this powerful and clean energy source. Electricity from offshore wind is generated by wind turbines located in bodies of water, usually oceans or large lakes. But why put them in water, you ask? Let's break it down. First, let's consider the benefits. 1. Stronger and more consistent winds. Winds over the ocean are typically stronger and more consistent than on land. This means offshore turbines can generate more electricity. 2. Less visual and noise impact. Offshore turbines are far from residential areas, reducing noise and visual impact on communities. And 3. Space efficiency. Large wind farms can be built without the same land use concerns as onshore wind farms or solar panels. This is particularly beneficial for densely populated coastal regions. So, how does this work? Wind turbines convert kinetic energy from the moving wind into rotational energy and then into electricity. Here's a closer look at the process. Blades catch the wind. The wind turns the blades of the turbine. These blades can be over 80 meters long and are designed using advanced aerodynamic principles to maximize efficiency. Rotor spins the shaft. The rotating blades turn a low-speed shaft connected to a gearbox. Gearbox increases speed. The gearbox increases the rotational speed from about 30 to 60 rotations per minute to around 1000 to 1800 rotations per minute, which is suitable for generating electricity. Generator produces electricity. The high-speed shaft drives the generator. Inside the generator, the mechanical rotation is converted into electrical energy through electromagnetic induction, and finally, electricity transmitted to shore. The electricity is then transmitted via underwater cables to the shore and into the power grid. These cables are typically high voltage alternative current or high voltage direct current lines, depending on the distance to the shore. Now, let's consider some technical details of key components. 1. Blades. Made from lightweight composite materials like fiberglass or carbon fiber to withstand harsh marine conditions. Their shape and angle are optimized for capturing maximum wind energy. 2. Nacelle. This is the housing at top of the turbine tower, containing the gearbox generator and control systems. It's designed to protect these components from the salty and humid offshore environment. 3. The tower, usually made of steel and can be over 100 meters tall. The height allows the blades to reach higher and more consistent wind speeds. And 4. The foundation. Depending on the water depth, foundations can be monopile, jacket, or floating. Monopiles are used in shallow waters, jackets in deep waters, and floating foundations for the deepest locations. Let us think about environmental impact. Offshore wind farms have a much lower carbon footprint compared to fossil fuels. They don't emit greenhouse gases or air pollutants, helping to combat climate change. However, they must be carefully located to minimize impacts on marine life and ecosystems. Detailed environmental impact assessments are conducted to understand potential effects on marine mammals, fish, and birds. Marine life. Measures are taken to protect marine life, such as designing turbines to minimize noise during installation and operation. Research is ongoing to understand and mitigate impacts on fish and marine mammals. Regarding birds, careful site selection helps to avoid major bird migration routes. Monitoring and technologies such as radar systems are used to reduce bird collisions. Now, let's consider challenges and innovations associated.
Okay, so there is more to that video, and feel free to check that out on our YouTube channel. For the purpose of today's session, I'm just going to show you that short clip. So as the video explained, wind turbine turns wind energy into electricity using the aerodynamic force from the rotor blades. And when wind flows across the blade, the air pressure on one side of the blade decreases, creating both lift and drag. And the force of the lift is stronger than the drag, and this causes the rotor to spin. As can be seen in the schematic, then the rotor connects to the generator, and this transition of aerodynamic force to rotation of a generator creates electricity. There are two main types of wind turbines. The first one there you may very well be more familiar with is the horizontal axis turbine. This is most commonly they have 3 blades and operate upwind, with the turbine pivoting at the top of the tower so the blades face into the wind. Secondly, we have vertical axis wind turbines. They look a bit like a whisk, and these turbines are omnidirectional, meaning they don't need to be adjusted to point into the wind to operate. And as you can see there, they can also be installed on the top of buildings, so we can use existing structures and harness energy from those. Some applications. So this schematic really shows the scale of these things, and as the video mentioned, the difference in size between onshore wind turbines and offshore wind turbines. Land-based wind turbines range in size from 100 kilowatts to as large as several megawatts. And these are currently with a hub height of about 89 meters. And looking forward to 2035, we're expecting the hub height to be 130 meters. Whereas in comparison, the offshore wind turbines by 2035, we're looking to, for the largest ones, having a hub height of 150 meters with a capacity of 17 megawatts. So a big difference. And actually in the news fairly recently that Germany are currently building the world's tallest turbine. And this is over 360 meters high. So whereas I used to say the turbines were not quite as tall as the Eiffel Tower, by summer 25, when this is expected to be finished, the tallest wind turbine will in fact be taller than the Eiffel Tower. So yeah, a huge investment, and that's to harness the higher altitude winds with an aim to generate about 40% more energy than traditional turbines. So larger wind turbines are also more cost effective and are grouped together into wind plants, which provide bulk power to the electrical grid. And offshore wind turbines do not have the same transportation challenges of land-based wind turbines, as the large components can be transported on ships instead of on our roads. And these turbines are able to capture the powerful ocean winds and generate vast amounts of energy. So applications. When wind turbines of any size are installed on the customer side of the electrical meter, these or are installed at or near the place where the energy they produce will be used. This is called distributed wind. And many turbines used in distributed applications are small wind turbines. So things that you can see on the slide here. And also I've been watching a lot of kids TV recently. So Teletubbies have also got a wind turbine as well. So hopefully they generate all of their energy they need to use from that turbine. No special effects on the top image, I'm afraid. So these can be used in hybrid energy systems with other distributed energy sources, such as microgrids powered by diesel generators or batteries and photovoltaics. These systems are called hybrid wind systems and are typically used in remote off-grid locations. Some advantages of wind energy. So it offers many advantages, which explains why it's one of the fastest growing energy sources in the world. And research efforts are aimed at addressing the challenges to greater use of wind energy. Wind power is cost effective. Land-based utility scale wind is one of the lowest priced energy sources available today. It also creates it's a source of creating green jobs, and it's a clean, sustainable fuel source. Wind turbines can also be built on existing farms, so it's a good use of potentially excess land or farmers looking to diversify what they're doing on their land. Some disadvantages or challenges. It must still compete with conventional generation sources on a cost basis. So some of these installations are obviously quite expensive, the initial investment. Again, they're often located in remote locations, far from the cities where the electricity is actually needed. So we need to think about infrastructure to get the electricity, to transport the electricity to where it's actually needed. And it might cause noise, aesthetic pollution, and harm wildlife. And as the video showed, wind resource development might not be the most profitable use of the land. So in terms of environmental impact, both onshore and offshore has a relatively low environmental impact compared to things like fossil fuels. And that's always going to be the thing that we're replacing is fossil fuels. But there are some important environmental considerations to consider. Onshore wind power may disrupt the land use and habitats. It might disturb local habitats and ecosystems. A wildlife impact, it can also be a threat to bats and of course birds as well. It can be a noise and visual impact, so nearby residents can be affected and may not want their nice looking landscape to be affected detrimentally. Carbon footprint. So although wind power itself is emissions free, the manufacturing, transporting and installing the turbines produces some greenhouse gases. And over their lifetime, these are offset. Many of these offset these emissions many times over, but still they do have a footprint associated with the manufacturing process. And soil and water impact. So the construction and maintenance can lead to soil erosion and changes in water flow, potentially affecting the agriculture and local water supplies. So environmental impact of offshore wind power. As the video showed, we could disrupt marine ecosystems, especially during construction. Bird collision risks, and particularly disrupting migratory species. However, it has been found that offshore locations often result in fewer collisions compared to onshore sites. Artificial reefs. This obviously changes the biodiversity, but has been shown to actually attract marine life and increasing the biodiversity. Again, the visual impact. Offshore wind farms are generally far from the coast, reducing visual impact on landscapes. But large projects near the shorelines may become more popular and can therefore affect the coastal views. Operational carbon emissions. So even though these installations have slightly higher carbon emissions during the construction and maintenance. This is due to the complex logistics of forming these wind farms at sea, but are still far lower in lifetime emissions than fossil fuels. Both onshore and offshore wind power present manageable environmental challenges and play a crucial role in reducing greenhouse gas emissions and mitigating climate change. Moving on to hydro energy. As a renewable energy source, hydropower is one of the most commercially developed. By building a dam or barrier, a large reservoir can be used to create a flow of water that will drive a turbine generating electricity. This energy source can often be more reliable than solar or wind power, especially if it's tidal rather than river, and also allows electricity to be stored for use when demand reaches a peak. Like wind energy in certain situations, hydro can be more viable as a commercial energy source, dependent on the type and compared to other sources of energy. But depending very much on the type of property, it can be used for domestic off-grid generation as well. The theory is to build a dam on a large river or body of water that has a large drop in elevation. A reservoir can be used to create a controlled flow of water that will eventually drive a turbine, generating electricity. The dam will store a lot of water behind it in the reservoir. Near the bottom of the dam there, you can see on the slide, there is the water intake. Gravity causes it to fall through the penstock, like the big slide sort of part, and down in through a turbine propeller, which is then turned by the moving water. The shaft then from the turbine goes up to the generator, which produces the power, and this then is connected via power lines to carry electricity to the home and surrounding industries. The water continues past the propeller through the tail race into the river past the dam. And hydroelectric plants are more efficient at providing for peak power demands during short periods than fossil fuels and nuclear plants. And one way of doing that is by using pumped storage, which reuses the same water more than once. Okay. And then so some hydropower has been used for generations to provide countries with reliable fossil fuel-free electricity. It's not a new technology, but it is becoming increasingly more popular as we're shifting to net zero. Some advantages: it's obviously a renewable energy source with low emissions, very reliable and fairly safe. However, disadvantages are that there's some environmental consequences. We're obviously disrupting a lot of land and the water source. Consequences for potentially native fish species. And generally, though, the pros will outweigh the cons in terms of how much power we can generate, because water can be relied on 24/7 in this technology, unlike solar or wind. We also have, they are obviously expensive to build and have a potential of drought or maybe limited reserves, depending on the specific climate and geographical location. Tidal energy. This is another form of hydro, works at a very similar method. It uses twice daily tidal currents to drive turbine generators. Although tidal flow, unlike some other hydro energy sources, isn't constant, it is highly predictable, so can therefore compensate for the periods when the tidal current is low. Here at Swansea Bay, we have the Blue Eden Tidal Lagoon set for development, set to feature underwater turbines generating 320 megawatts of renewable energy. However, the project is still in limbo a little bit due to money, I think. Tidal energy, how does this work? Well, it's highly predictable and it can therefore compensate for periods when the tide current is low. So we can have three main types of process. We have streams where tidal energy, turbines are placed in the tidal stream. And this is a fast flowing body of water which is created by the tides. A turbine is a machine that will make energy from a flow of fluid. So this then turns the turbine similar way to hydro energy to generate electricity. Barrage is another type of tidal energy generator. This uses a large dam, and these can be constructed across tidal rivers, bays, and estuaries. And finally, the tidal lagoon. This is an energy generator involving the construction of lagoons, which is a body of ocean water that is partly closed by a natural or man-made barrier. And then tidal lagoons might also be estuaries and have fresh water emptying into them as well. And unlike barrages, however, tidal lagoons can be constructed along the natural coastline. So hopefully we will see something down in this area soon. Some advantages of tidal energy: it's a known green energy source and it emits 0 greenhouse gases when running, and also it doesn't take up too much space. It's more reliable than hydro energy because the tides are predictable. And some of the disadvantages are that environmental consequences, so we can have effects on nearby animals, plants, and biodiversity, and so on, might disrupt the sensitive marine life. Again, expensive to build, and potentially formation of silt behind the barrage, affecting efficiency. And there are actually very few suitable sites for constructing these barrages, so things have to be correct for even the possibility of these barrages to be built. So hydrogen as a fuel source, this is a topic that could be presented on its own in itself. It's such a broad topic. However, it was worth mentioning today as it links in well with renewable energy technologies. Hydrogen is an energy carrier and can be produced from a wide variety of sources and is used for refining petroleum, treated metals, producing fertilizer, processing foods, and so on. It can also be produced from renewables in a number of ways. Typically, the process uses renewable electricity to split water into hydrogen and oxygen in an electrolyzer. Hydrogen can be stored on sunny days when the rate of renewable energy and in turn hydrogen production exceeds hydrogen demand. Stored hydrogen can be converted back to electricity with a hydrogen fuel cell to produce a continuous renewable electricity supply, even during periods when the rate of renewable electricity production cannot meet demand. These hydrogen fuel cells have recently been also used for transportation in hydrogen powered cars. Now, the reason I've mentioned hydrogen is this. So something called green hydrogen, which is one method of generating hydrogen. The process uses renewable electricity to make hydrogen from electrolysis, with oxygen being the only byproduct. So as can be seen from the schematic, the hydrogen is made from electrolysis, and then the hydrogen is stored underground. This stored hydrogen can then be used for direct reduced iron, or DRI, production, with water being, again, the only byproduct. And finally, with DRI and scrap used to make steel via electric arc steelmaking, powered by yet more renewable energy. So it might look like an ideal circular process, and that is what HYBRIT, which is hydrogen breakthrough technology, companies are trying to do. However, at the moment, the technology is currently very expensive and may not be economically viable. The work is going on to make this sort of process possible. So some comparisons. While wind and hydropower, as you've seen, are very consistent, wind turbines may have a higher maintenance cost as the turbines are larger and may break down more easily because of the moving parts. Solar power is a cheaper energy source, but hydroelectric power is more consistent since water is rushing through the turbines 24 hours a day, compared to the sun that only shines during the day. As I've shown, hydrogen fuel cells have been introduced. However, emissions generated during extraction vary between methods, and the method for green hydrogen is currently very expensive. As for biofuels, which I haven't mentioned in this presentation, but it is in the main course, these are generally worse for environmental impact. With the biofuels, you also need to constantly cut down sort of trees and plants to keep your stock topped up that will be burnt for fuel. But with solar, wind, or hydropower, generally the resources are plentiful and do not emit carbon dioxide when generating energy or powering a plant, for example. Some future trends in Wales. This is a summary from the Welsh Government document, Future Potential for Offshore Wind in Wales. And despite the dominance of fossil fuel generation in the current mix, government policy away from fossil fuels towards more renewable generation, combined with several plants coming towards the end of their operational lifetime, suggests that considerable changes can be expected over the coming decade and beyond. Wind and solar power are expected to make up a rapidly increasing share of the energy mix in order to replace fossil fuel assets coming offline and to meet the UK and Welsh renewable energy and decarbonisation targets. The relative share of solar, onshore wind, offshore wind, and other renewables is less clear, and it is expected that onshore wind and solar will see an increasing share of decentralized generation, which is where it's used, the energy is used more locally, while offshore wind has the potential to provide large-scale centralized generation capacity to the grid. Wave and tidal power. So these could also play a role in Wales's future energy mix. Several demonstration wave and tidal stream projects are in development in Anglesey and also Pembrokeshire, i.e. the Celtic Freeport, which has wind and hydrogen energy. Could be deployed at scale if they can demonstrate cost competitiveness with other generation sources. Tidal lagoons are also being explored, for example, Swansea Bay Blue Eden Tidal Lagoon, although concerns over the cost to UK consumers. And some more about offshore wind in Wales. To meet its decarbonisation targets by 2030, Wales has committed to investing in offshore wind. The route to market for onshore renewables isn't as clear, and along with marine energy technologies being expensive by comparison, offshore wind power could be vital to meeting these targets. This is an interesting statistic. An additional 2 gigawatts of offshore wind power could be delivered by just 2 to 3 projects in Wales, and therefore taking the total offshore wind capacity to 2.8 gigawatts. This could nearly meet all of Wales's 70% renewable energy target by 2030 by just 2 to 3 large offshore wind projects. Again, the Celtic Freeport builds on from what the Pembroke Dock marine development has been doing and further accelerates Wales to a net zero economy. Green energy infrastructure focusing especially on clean energy like hydrogen and offshore wind. It's expected to generate around 16,000 jobs for the area and generate significant investment, up to $5.5 billion, sorry, that they're hoping to generate. And it's mostly focused on floating offshore wind farms, hydrogen production, and sustainable fuel initiatives. And the overall aim is to encourage trade, manufacturing, and of course investment into the region. And that's all I wanted to talk to you about today. Obviously, there's more in the full online course, and we can, on the slide there, you can see the QR codes for our LinkedIn, our website, and also our YouTube channel. So please do take a note of those and check those out when you can. And that's all from me. So thanks for listening.